Today we're going to talk about using the HyperProtect Crypto Services Management utilities to initialize a service instance in the IBM cloud. This presentation assumes that you have just provisioned a service instance in the cloud and the crypto units are in an uninitialized state. Before you can use the service instance to run workloads, you must load the master key registers in the crypto units. This presentation will show you how to do that using the HyperProtect Crypto Services Management utilities. There are two separate management utilities, a smart card utility program for setting up the smart cards you will use, and a trusted key entry application for working with your service instances. Before you can use the trusted key entry application, you need to create a set of smart cards to hold signature keys and master key parts. The smart card utility program lets you do that. Service instances can be managed using 1 to 8 administrators, and you need 2 or 3 master key parts to load the master key register. The smart card utility program lets you create 2 types of smart cards, a CA or Certificate Authority smart card and an EP11 smart card. The CA smart card defines what I will call a smart card zone. A smart card zone is a set of smart cards that are cryptographically tied together. A CA smart card is needed to create the EP11 smart cards. The CA smart card can also be used to reset a blocked pin on an EP11 smart card in the zone, but we will talk about that later. The other type of smart card that HPCS management utilities use is the EP11 smart card. EP11 smart cards can store a single signature key and up to 85 master key parts. There are different ways you can set up your smart cards to initialize a service instance. A bare bones configuration would be to create a single CA smart card and a single EP11 smart card. This is not recommended for production environments. The EP11 smart card would contain a signature key and 2 or 3 master key parts. This may be suitable for a test or development environment where you are not working with real data that must be kept secure. Best practice for production environments is to implement dual control. Dual control means that more than one person must cooperate to perform administrative actions such as loading the master key registers. Regardless of what smart card configuration you choose, you should always create backup copies of your smart cards and store them in a safe place. That way, if a smart card is lost or damaged, you can still work with your service instance. A more secure configuration is to create a CA smart card and 4 EP11 smart cards. One EP11 smart card will contain just a signature key. The other 3 EP11 smart cards will each contain a single master key part. With this configuration, all 4 EP11 smart card owners need to cooperate to load the master key register. Another more secure configuration is to create a CA smart card and 4 EP11 smart cards. 2 EP11 smart cards will each contain a signature key. The other 2 EP11 smart cards will each contain a single master key part. As part of configuring your crypto units, you can choose how many signatures are needed to perform some administrative commands, such as loading the master key registers. If you indicate that 2 signatures are required, again, all 4 EP11 smart card owners will need to cooperate to load the master key register.
Okay, let me start the smart card utility program and we can see how this works. There are some pull-down menus at the top. One pull-down menu lets you work with CA smart cards, and another pull-down menu lets you work with EP11 smart cards. For the CA smart card, there are 3 options. The first one loads custom software onto a smart card and creates the CA smart card. The second option lets you create a backup CA smart card for an existing CA smart card. And the third option lets you change the CA smart card pins. For the EP11 smart card, there are 4 options. The first one lets you load custom software onto a smart card and create the EP11 smart card. And this also creates keys on the smart card and certificates on the EP11 smart card. The second option lets you enter the PIN you want to use for the EP11 smart card and a description for the EP11 smart card. The third option lets you unblock the PIN on the EP11 smart card if the smart card has been blocked because the PIN has been entered incorrectly too many times. And then the fourth option lets you change the PIN on the EP11 smart card. So let's go ahead and create a CA smart card. So we'll select the first option, and it's asking for a smart card to be inserted in reader 1. So I'll insert the smart card in reader 1 and click OK. Now, because I've used this smart card before, there's already some custom software on the smart card, but we can just ignore that and continue. You actually get 2 warnings, so we can ignore the second warning also. And at this point, custom software is being downloaded onto the smart card, and that takes a little bit of time to do, so I'm going to pause the presentation at this point. Okay, we're back. It's asking for the first PIN for this CA smart card to be entered, so I will enter that. And I have to enter it twice, so I'll enter it a second time. And now a second PIN for the CA smart card, so I'll enter that. And enter it twice. Okay, so now it's asking for a zone description for the zone that we're creating. And I'm just going to call this production. And it wants a description for the smart card. So I'll call that production CA card. Okay, and at this point, it is generating keys on the smart card and creating some certificates that the smart card will use, and that also takes a little bit of time. So I will pause the presentation here. Okay, we're back, and the CA smart card has been created successfully. So you can see we created a CA smart card that's in reader 1. It has the zone description that we entered, production, and it has the card description that we entered. So at this point, the CA smart card has been completely created, and you could create a backup smart card and should create a backup CA smart card by selecting the second option here. I won't go through that in this presentation, but it's very straightforward. You just select the option and then follow the prompts. So at this point, we can create an EP11 smart card. So I will select the first option in the pull-down menu. And the first thing it asks for is it needs a CA smart card for so it can enroll the EP11 smart card in a particular zone. So I'll insert the CA smart card in reader 1. And we're required to enter the pins before we can use the CA smart card, so I will do that. And the second pin. And then it wants a blank smart card to set up as the EP11 smart card in reader 2. So I will insert a smart card in reader 2 and click OK. And again, because I've used this smart card before, it's not empty, so we get a warning about that, and we can ignore that. And we get 2 warnings, we'll ignore both warnings. Okay, so at this point, it's downloading custom software onto the smart card, and it will go ahead and create some keys on the smart card and set up some certificates. So while this is running, let me say a few things about the smart card pins. The CA smart card has 2 6-digit pins. To use the CA smart card, you must enter both pins, as we just saw. If you enter a pin incorrectly, you can try again, but if you enter a wrong pin 5 times, the CA smart card is blocked and becomes permanently unusable. So you want to be very careful about entering the CA smart card pins correctly. There is a counter on the CA smart card for each pin that keeps track of how many times an incorrect pin was entered. When you enter the pin correctly, the counter is reset. So the limit of 5 incorrect pins is 5 in a row. It's not over the lifetime of the smart card. An EP11 smart card has just one 6-digit pin. You are given 3 chances to enter the pin correctly before the smart card is blocked. But if the smart card is blocked, you can recover. To recover, you need the CA smart card. As we saw in the EP11 pull-down menu, there is an unblock EP11 smart card option that you can select, and you just follow the prompts, and that will guide you through unblocking the pin there. Okay, so the EP11 smart card has been created. At this point, it's running some initial diagnostics on the EP11 smart card, and that takes a little bit of time. Okay, so the application went out, and we see that the CA smart card is still plugged in reader 1, and the EP11 smart card that we just created is in reader 2. The EP11 smart card has the same zone description and zone ID as the CA smart card, as it should. This shows that there's no card description associated with the EP11 smart card, and the pin status is not set. So we will go ahead and take care of those 2 things by selecting the second option. And it's asking for the pin that we want assigned to this EP11 smart card. So I will enter that twice. And the second time. And it's asking for a description for the EP11 smart card. I'm going to use this to hold an administrator's signature key, so I'm just going to call this admin 1. And it went ahead and did that. So now we can see that the pin status is okay. So there's a pin associated with the smart card, and the description that we wanted associated with the smart card has been entered. So I plan to use that first configuration where we have 4 EP11 smart cards, 1 with a signature key and 3 with master key parts. I won't go through and create the other 3 EP11 smart cards that we need. I'll switch to using a set of smart cards that I created in advance. And we can switch to the other application, the trusted key entry application, to do that. Now, before you can start the trusted key entry application, you need to log into the IBM Cloud using the IBM Cloud command line interface, and you need to select the resource group that you're going to work with. So I've already done that, so we can go ahead and just start the application. If you don't do that, you'll be reminded that you need to do that when you try to start this. So it's going out and it's querying the resource group to see what service instances are associated with it. Okay, and this is showing that there are 2 service instances associated with the resource group, and each service instance has 2 crypto units assigned to it. This selected column says that we have decided we're going to work with all 4 crypto units. If I only wanted to work with some of them, I could click on the Remove Crypto Units button. And let's say we only wanted to work with the second service instance. And you can see the selected value has changed to false for the first 2 crypto units. So subsequent commands issued through this application will only be sent to these 2 crypto units in this case. I want to work with all 4 crypto units, so I'm going to add those first 2 back again. And this is showing that all 4 crypto units are selected. So we can take a quick tour through the other panels in this application. Let's look at the administrators panel. So this shows what administrators have been loaded into the crypto units. And because we're assuming that we're starting with uninitialized crypto units, these are brand new service instances, there aren't any administrators installed. We'll have to install some administrators as part of the setup. This next panel shows how signature thresholds are set for each crypto unit. The signature threshold controls how many administrative signatures are required for some commands. Some commands require only one signature, even when the signature threshold is set to a higher number. The signature threshold can be set to any number between 1 and 8. There is a separate signature threshold for removing an administrator called the revocation threshold, and that's this value here. Right after a service instance has been provisioned, the crypto units are in an uninitialized state called imprint mode. No signatures are required on commands sent to the crypto unit, but most commands are disabled. The only commands you can execute in imprint mode are to add and remove administrators and to zeroize the crypto unit if you want to start over from scratch. To zeroize the crypto unit, you would click on this button here in the panel. In imprint mode, the signature threshold and revocation threshold are 0. To exit imprint mode, you would set the thresholds to a value greater than 0. The two threshold values, the signature threshold and the revocation threshold, don't have to be set to the same value. The command to exit imprint mode must be signed, and the number of signatures required is the new signature threshold value. And before you can exit imprint mode, you must install the administrators you will use to sign the commands. Okay, this shows how the master key registers are set in the crypto units. So there are actually two master key registers on each crypto unit. There's a new master key register and a current master key register. So this panel shows how the new master key register is set for all 4 crypto units and how the current master key register is set for all 4 crypto units. I should explain why there are 2 master key registers. The value in the current master key register enciphers the contents of key storage associated with a service instance. So since we're assuming that we just provisioned our service instances, there isn't a key store with entries in it that are enciphered with the current master key register value. But after you have set up your current master key register and started running workloads, your key store will start to be filled with entries that are enciphered using the current master key register value. If at some point you want to change the current master key register value, you would need to re-encipher the contents of key storage. So for that, you would need both the current master key register value and the new master key register value that you want to switch to. So that's why there are 2 registers associated with each crypto unit. And the last tab on the panel is the smart card tab, and this lets you work with EP11 smart cards. So I'm going to insert an EP11 smart card in reader 2 and display what's out there. And this shows the EP11 smart card. It shows the card description. On this smart card, I want to create an administrator signature key that we will use for signing commands. So I can do that. I can create the signature key from this panel. I would click on this Generate Signature Key button, and let me go ahead and do that. That's asking for the administrator name. And I'm just going to call this admin1, not being very creative. And it needs to know the PIN for the smart card, so I will enter the PIN. And it's generating a signature key and saving it on the smart card. So it did that. It generated a signature key, saved it on the smart card. The subject key identifier is a hash over the public part of the signature key. It's not the signature key itself. It's just something that lets us uniquely identify the signature key. And we're done with that. So now the tab here shows that there's an administrator signature key on the smart card, and that's all that this smart card contains. So let me switch to a different smart card. I'll load a different smart card in the reader and display the contents. And this shows that the card is empty. We call this smart card MK port 1. So we're going to generate a master key part and save it on the smart card. So to do that, we can click on the Generate Key Part button. Let me do that. And it's asking for the PIN for the smart card. And it wants a description. I'm just going to call this MK Part 1. And it went out and it generated a random master key part and stored it on the smart card. So this shows the description that we just entered for the key part and also a verification pattern for the key part. The verification pattern is a hash over the key part. It's not the key part itself. Again, just something that lets us uniquely identify the key part. So we can generate a signature key or a key part from the smart card tab. We can generate a key part also from the master keys tab. There's a button, Generate Key Part, on this panel as well as on the smart card panel. The same function gets invoked from both places. It's just two different places where we can invoke it. And we can generate a signature key from the administrator's panel. There's a Generate Signature Key button on that panel. So going back to our smart card panel, I need to generate 2 more master key parts, so that we'll have 3 key parts that we can work with. So let me do that. So I inserted a new smart card in Reader 2. Click on Generate Key Part. Wants the PIN. Wants a description. And it went ahead and did that. And then I'll insert a 3rd EP11 smart card in the smart card reader. So it shows the new card is in the reader. It's initially empty. We'll click on Generate Key Part and enter the PIN. Okay, so we've generated 3 key parts and a signature key now at this point. So before I go on, I'd like to talk a little bit more about the other 3 buttons, the bottom 3 buttons on this panel. So like I said at the beginning of the presentation, you should create backup copies of all of your smart cards. So for the CA smart card we saw, you can do that from the smart card utility program by selecting the backup CA smart card function there. To create a backup copy of an EP11 smart card, you would create a blank EP11 smart card using the smart card utility program. And then from this panel, you can click on the Copy Smart Card button, and that will let you select key parts and a signature key to copy from a source EP11 smart card to a target EP11 smart card. I won't do that here. You just click on this button and then follow the prompts. It's a pretty straightforward process. The other 2 buttons on this panel are for users who initialize their service instance using the TKE plugin for the IBM Cloud command line interface. That's another way that you can initialize your service instance. It doesn't use smart cards. It uses software running on a workstation. In that case, the signature keys and master key parts are saved, encrypted in files on the workstation. So if you initialized your service instance using the TKE plugin and you want to convert to smart cards, these 2 buttons let you transfer a key part or a signature key that you created using the plugin. It lets you copy those to a smart card. So again, I won't go through that in this presentation. You just click on the button and follow the prompts. It's pretty straightforward. So at this point, we're ready to actually start sending commands to our crypto units. So let me go back here. So This shows that we're working with all 4 crypto units. There are no administrators installed. The first thing we need to do is to install an administrator. So I'll click on the Add Administrator button. And it's asking for a smart card with an administrator signature key on it to be inserted in Reader 1. So I will do that. And it wants the PIN. So it's reading right now the public part of the signature key from the smart card, and it's creating a certificate using that and also with the administrator name in it. And it's installing that certificate on the 4 crypto units. So that happened pretty fast. You can see the same administrator has been installed on all 4 crypto units, and it gives the subject key identifier for the administrator's signature key. Okay, so a word of warning at this point. I have a smart card with an administrator signature key plugged into Reader 1, and I've entered the PIN. So Reader 1 is used to generate signatures when required. And as long as the card is in the reader and the PIN has been entered, this application will automatically go out and generate the signatures that it needs. And there won't be any warning or indication that that's taking place. And the reason for that is these commands are, in this case, we're broadcasting commands to 4 different crypto units. You need a signature for each crypto unit that you're sending the command to. And it would be really annoying to be prompted each time for a signature key. So we just go ahead and do it. So the owner of the smart card with the signature key on it needs to be present for the operations that are taking place and needs to approve of what's being done. And when they're done with the operations, they need to remove the smart card from the reader so it isn't accessed for any other signatures. So just to drive that home, I'm going to pull the smart card out of the reader so that you can see that you're prompted when you need signatures. So we loaded an administrator on the 4 crypto units. We are in imprint mode still at this point, so no signatures were required on that command. The next step is to exit imprint mode by setting the signature thresholds to a value greater than 0. I'm just going to set the signature threshold value to 1. So I'm going to click on the Change Signature Thresholds button. It asks for the new signature threshold value. I'm just going to make that 1. And the new revocation threshold value, also make that 1. Now this is a signed command, and the number of signatures required is the new signature threshold value. So since I selected 1, it's saying I need 1 signature on the command. It's asking for a smart card to be inserted in the reader. I'll reinsert the EP11 smart card in the reader and click on OK. And it wants the PIN. So we are no longer in imprint mode. We've set our signature threshold to 1. So now we can continue and load our master key registers. So again, I'm going to pull the smart card out of the reader just so it isn't automatically accessed for signatures. I mean, you can leave the smart card in the reader. This is just to illustrate where signatures are required. The first thing we want to do is to load our new master key register. So to do that, I'll click on the Load button. Doing some pre-checks at that point to make sure we're in the right state to be able to do the load. Okay, so at this point, the first thing that needs to happen is on all of our target crypto units, an importer key needs to be generated, and the public part of the key needs to be returned to the smart card actually, so that they can re-encipher the master key part for while it's transferred from the smart card to the target crypto unit. So I'm going to insert the smart card back in the reader and click on OK, and it wants the PIN. So now this importer key is being generated on all of the target crypto units. And we're going to use 3 master key parts in this presentation. So we're going to load the first master key part. So it's asking for a smart card with a master key part in Reader 2. And I will enter that, insert the smart card in the reader, and enter the PIN. And it goes out, the application goes out and checks to see what master key parts are installed on the smart card. We only have one in this case, so that's the one I'm going to pick. And it's going through and enciphering that master key part on the smart card for the 4 target crypto units. And that takes a little bit of time to do. Okay, so now we're ready to load the second key part. It's asking for a smart card. Wants the PIN. And again, it queries to see what key parts are on the smart card. Only one again. So I will select that. Okay, and now we're ready for the third key part. So I will insert the third smart card in the reader and enter the PIN. And there, again, there's only one master key port on the smart card, so I will select that. Okay, so each of the master key parts is enciphered using the importer key for the target crypto unit. Because this is the last key part that we're processing, it will assemble the full command and send it to the target crypto units. So we will see the status of the new master key register change in just a few seconds on all 4 crypto units when the command to load the new master key register is executed. Okay, so that it happened. So you can see the same master key register value has been loaded in all 4 crypto units. The verification pattern is the same for all 4 of them. And the new master key register is in the full uncommitted state. So in order to continue processing, we need to commit the value in the new master key register. So to do that, I will click on the commit button. This command requires the full signature threshold number of signatures. In this case, since we set the signature threshold value to 1, that's just 1. So I inserted a smart card in the reader and will enter the PIN. And it went ahead and did that. So now the new master key register has been fully committed. If you were changing the current master key register value, if the current master key register was not in the empty state, but had a value in it, and that value was enciphering the contents of key store, this is the point at which you would re-encipher your key store, because both the current master key register value would be available and a committed new master key register value would be available. Since we're starting with brand new service instances, there is no value in the current master key register. We don't have to worry about re-enciphering key store, and we can go immediately to the set immediate operation. This is what promotes the value in the new master key register to the current master key register. And we get a warning about this, because if you mess up at this point, you would make the contents of your key store unusable. So since we know what we're doing, we can say, yes, we want to continue. And it's doing some pre-checks to make sure we can do it. It needs 1 signature, so I'll insert the EP11 smart card back in the reader and click OK and enter the PIN. And it went ahead and did that. So the value in the new master key register was promoted to the current master key register. You can see the verification pattern. It was the same, that moved up here. And the status here is valid. The new master key register has been cleared in all 4 crypto units because we don't need it anymore. So at this point, you're all set to go. Your current master key register has been fully loaded, and you're ready to run workloads on your service instances.